Okay, this lesson is on using the stoichiometry, the stuff from the last unit, in using it with solutions. We call this gravimetric analysis. So if you remember back from the previous unit, stoichiometry has to do with the amounts of reactants and products in the chemical reactions. And so we use the number of moles for that. We're going to use a very similar method for solving these kinds of problems, but we may need to use concentration calculations because if we're, for example, in a double displacement reaction using the ionic compounds, in order to get those ionic compounds to actually react, we quite often have to dissolve them in water. And so we use these aqueous solutions. And in order to understand how much there is, if we have a solution of something, obviously there's going to be a concentration related to that. Now, because we are looking for quite often the parts of the reaction that are involved in producing a certain product, we sometimes don't need to worry about all of the other stuff that's still floating around in the solution. And so we use what's called a net ionic equation sometimes to simplify the problems for us. And later in the slides, I'll explain what that is. So let's start with this example here. If you've ever eaten rhubarb has a very tangy taste to it. But you eat the stalks of the rhubarb plant. Do not ever eat the leaves. The leaves are poisonous. They have something called oxalate ions in them. And oxalate ions are very soluble. And if they happen to get into your system, they will cause respiratory failure. So always be careful of that sort of thing. Make sure that if you eat rhubarb, eat only the stalks. They're fine. Okay, so here's the question. To determine the concentration of oxalate ions, you ground up excess calcium chloride and add it to these oxalate leaves, the rhubarb leaves, and add it to a solution, and then you get a precipitate of calcium oxalate. And from that, you can figure out what the mass percent of oxalate ions is in the leaves. All right, so let's say we have 238.6 grams of leaf, and we end up with 0.556 grams of calcium oxalate precipitate. What's the mass percent of the oxalate ions in these leaves? All right, so writing it out so that we can understand what's happening. We have the mass of the leaves. We have the mass of calcium oxalate. And so what we want to know is what's the mass percent of oxalate ions, just the oxalate ions. Normally it would be some soluble cation that goes with it. You wouldn't have just the oxalate ions, but they're the ones that we're dealing with. So we're going to ignore the cation and we're going to deal with just the oxalate ions. So we need the mass of oxalate ions over the mass of the leaves times 100%. Okay, and so first of all, to figure out the mass of calcium oxalate, we figure out the number of moles of calcium oxalate. So then we're going to use the number of moles of calcium oxalate because that'll be the same as the number of moles of oxalate ions. And so then the number of moles of oxalate ions, we'll figure out the mass of the oxalate ions. Okay, so that's how that's going to work. So that's just regular stoichiometry stuff that we've done before. And then we do the mass to figure out the mass percent. Is that we are going to take, first of all, the number of moles of calcium oxalate, the precipitate, and we're going to divide by the molar mass of calcium oxalate, and we're going to figure out the number of moles. All right. So this is the number of moles of calcium oxalate. So for every calcium oxalate, there's one oxalate ion in there, right? So the number of moles of calcium oxalate then is the same as the number of moles of calcium oxalate. All right. Now, the reaction that's happening is the oxalate ions, the cation isn't involved. It'll form a soluble salt with chlorine. Let's say it's sodium or something like that. So we get sodium chloride over here. So we'd have Na2C2O4 as the compound. But the oxalate ions is what we're dealing with. Okay, that's going to react with the calcium chloride and give us the calcium oxalate as a precipitate. Now, this is just our reaction equation. Now, remember that ionic compounds in aqueous solution break up into the ions. So water surrounds them, brings them into solution, and that's how they dissolve. So as a result, we get, if we write down all of the ions in the solution now, what we get is we get oxalate ions, we get calcium ions, we get chloride ions. All right. So the calcium and the chloride, so the oxalate ions and the calcium ions, they're going to form this precipitate. Once this becomes a precipitate, a solid, it's insoluble in solution, and so as a result it comes out and makes a little lump at the bottom of whatever color the stuff happens to be. The chloride ions, though, because they're still soluble, they'll stay in solution. This is what we call our total ionic equation. So TIE stands for total ionic equation. But we really don't care about these chloride ions. They're just sitting there, because you'll notice there's 2 chloride ions at the reactant side, 2 chloride ions on the product side. They're just sitting there watching the show. Right? They're not participating in what's happening, so they're what we call spectator ions. So if we take out spectator ions, whatever cation happens to be with the oxalate ions would be a spectator ion as well. So let's say it's sodium ions. Those are all spectator ions. So we ignore those, we get what we call the net ionic equation. And the net ionic equation is simply the oxalate ions with the calcium ions to give us the precipitate, calcium oxalate. All right. All right. Now, the ratio, as I mentioned earlier, of oxalate ions to calcium oxalate is a 1-to-1 ratio. All right. So as a result, then, we're going to have the same number of moles of oxalate ions as we have calcium oxalate. So then the mass of the oxalate ions, number of moles times molar mass, works out to 0.3820 grams. We can use this now to figure out the mass percent. All right, so now we're going to use the mass percent divided by the mass of the leaves, 0.16%. Okay, or 160 parts per million. Okay, does that make sense? Okay, let's try another example. Okay, so lead is another highly poisonous metal. You don't want any in your drinking water. So if we have 30 milliliters of 0.075 molar of sodium sulfate ions added to 25.8 milliliters of 0.015 molar lead 2 nitrate, what mass of lead 2 sulfate will precipitate? All right, so this is just a limiting reagent reaction question. Let's write down what we know and what we don't know and figure it from there. So sodium sulfate concentration and volume, lead 2 nitrate concentration and volume. So from that we can figure out how many moles we have of each. All right. What we're looking for is, the lead sulfate, lead 2 sulfate. All right. So first thing we need a chemical reaction equation, because we gotta get our coefficients and make sure everything's balanced. Make sure we understand the mole ratios. Find the moles of sodium sulfate and lead 2 nitrate. Determine the limiting reagent. Find the moles of lead 2 sulfate from the limiting reagent. Figure out the mass of the lead 2 sulfate. And there we go. All right, here we go. So there's the reaction equation. It's balanced. Okay, 1-to-1 to 2-to-1. All right, so moles of each of the reactants. First of all, the sodium sulfate. Mass by molar mass. Mass by molar. Number of moles times the concentration times the volume. Ooh, is it a Monday? We get 0.00225 moles. Number of moles of the lead 2 nitrate, same calculation, we get 0.00387 moles. So we have less of this, so the sodium sulfate tends to be our limiting reagent. All right. All right, so the number of moles of lead 2 sulfate is going to be the same as the number of moles of the sodium sulfate. And so that's going to give us that many moles. Figuring out the mass, we end up with 0.6823 grams. or correct sig digs 0.68 grams. All right, so there's the questions from the homework. This is the last week you have your textbook. You're going to be required to bring them back. The schedule should be coming out fairly soon if it hasn't already. And I will be emailing you when that does. And then you'll need to return textbooks, come and clean out lockers, that sort of thing. And that'll be pretty much it for the course. And then I will give you one more assignment this week as well. And that will tie things up, and then I'll decide if your mark goes up or not.